In the previous video, we were trying to work out the area underneath the sine of x function from 0 to pi, and this area here can be written as this. And then if whenever you want to find out the area underneath a function, you would integrate this thing here to give you capital F here, and then you would evaluate this thing here. So in the previous video, we did this. So we would integrate this sine of x to give us minus cos of x. But the thing is, when you integrate something, you should have a plus c. But the thing is, when you come to evaluate the area underneath a function, you don't put the c in here, because by right you should put the c. But when you come to work out the area underneath a function, you don't put the c. And the reason for that is because of this. Hang on. So when you integrate this, hang on, sorry. So remember the area here, this area here can be written as this. Hang on, can be written as this. Okay, from 0 to pi. So from 0 to pi. So to evaluate, so this area here can be written as this. So that area is equal to this thing here. But the thing is, when you integrate this, by right you should put a plus c, because when you integrate something, you're going to have a constant. But the thing is, we don't bother putting this c in here when we come to evaluate it, because when you put a c in here, so by right we should have a c. Okay. So now when you put the c in here, it will become this. Evaluate this thing first, and then take away this thing here. Okay, so first thing, evaluate this and then take away this. Okay, so evaluate this will give you well, you've got to put a pi into this x. So the first part would be minus cos. Remember, we're putting the pi into here. That will give us this pi here, and then we've got plus c. Okay, and then we've got to take away. And then take away this whole thing here. So take away, well, this whole thing here equals this thing here. Okay. So again, the c gets carried down here. But the thing is, the c gets cancelled out. That's why we don't bother putting the c in here when we come to evaluate the area. But let's just carry on here. So this thing, remember, cos of pi is negative 1. Okay, so your cos graph will look something like this. This here is 2 pi, this here is pi, and cos of pi here is negative 1. Just the cos of pi, okay? Just the cos of pi here. So this negative is still out here. And then you've got your c here, okay? And then cos of 0 is 1 itself. Okay, so this negative is on the outside. Okay, so this box here becomes this, because cos of 0 is 1, and then now this and this would become a positive, and here's the thing. So basically, when you are here, you can see that here a negative and a positive becomes a negative. So well, the point here is that the two c's here will cancel each other out. The two c's will eventually cancel each other out. So you will get to this stage here where you've got a positive c and a negative c. So they will get cancelled out, giving you 2. The point of this video is that you don't, when you come to integrate here, when you come to integrate this, by right you should put a c in here. But the thing is, because when you come to do this and then take away this, the two c's will cancel each other out. So when you come to do this, don't bother putting the c in here, because the c will get cancelled out. So when you come to evaluate this, just do it as normal without the c. Okay.